Hey everyone. We all think we know our body temperature. We grab a thermometer when we feel off, and we know a high number is usually a bad sign. But what if the real danger wasn't from a virus, but from a routine medical procedure? Today, we're going to take a journey from that familiar 98.6 degrees all the way to a rare and, frankly, terrifying medical crisis.
Okay, so let's just jump right in because the very first thing we have to do is question something we all learned as kids. That one perfect number for human body temp, 98.6 degrees Fahrenheit. Yeah, that's not really the whole story. In fact, for a lot of us, it might not even be our own personal normal.
So before we can even get into the extremes, we've got to get a clear picture of the baseline. What actually is a normal body temperature?
So it turns out normal isn't a single point on the thermometer at all. It's a range. Doctors call it normothermia. Your temperature naturally goes up and down. It's usually a bit lower when you wake up, a little higher in the afternoon, and it can even change depending on your age. So think of your normal temperature less like a single number and more like a neighborhood that you comfortably live in. All right, now that we've got our baseline, let's start turning up the heat of it. And this is where we hit a really important distinction that a lot of people mix up. When your temperature spikes, is it a fever or is it hyperthermia? They might feel similar, but what's happening inside your body is worlds apart.
So check this out. This is the key difference. Imagine your brain has a thermostat. With a fever, your body on purpose cranks that thermostat up. It's a strategy to fight off something like an infection. But with hyperthermia, your thermostat is still set to normal. It's your body's cooling system, your internal AC, that's just completely overwhelmed and failing on a super hot day.
And when that temperature gets dangerously high, we're talking over 104 degrees Fahrenheit, it gets a new name, hyperpyrexia. This isn't just you feeling unwell. This is a full-blown medical emergency. It can happen from a really bad infection or a serious case of heat stroke. Okay, so we've got fevers from being sick and overheating from the environment. That all kind of makes sense. But now we're going to take a sharp left turn into a situation that's much rarer and in a lot of ways much, much scarier. Let's talk about the anesthesia crisis.
And this is the question that changes the whole game. I mean, it's one thing to get sick or maybe push yourself too hard on a hot day. But what happens when the trigger for a life-threatening temperature spike is the very medicine that's supposed to keep you safe and comfortable during an operation? Well, the answer is a condition called malignant hyperthermia, or MH for short. And let's be clear, this is not a fever. It's not your typical hyperthermia. It is a violent, hypermetabolic firestorm that ignites inside the body, all because of a reaction to specific anesthetic drugs. The body's metabolism just goes into complete overdrive, generating a terrifying amount of heat. Now, the triggers for this are very, very specific. We're talking about a class of inhaled gases used for general anesthesia, plus a common muscle relaxant called succinylcholine. For almost everyone, these drugs are perfectly safe. But for a small number of people, they become the key that unlocks an absolute catastrophe.
So what's actually happening inside the body? Well, it's this crazy, devastating domino effect. The drug triggers this massive, uncontrolled flood of calcium into the muscle cells. All that calcium forces the muscles to contract and stay contracted. They become incredibly rigid. It's like an extreme full-body workout that you literally cannot stop. And that's what causes the body's metabolism and temperature to just skyrocket. Okay, so the big question is why? Why does this happen to one person and not another? The answer is literally written into their DNA. Malignant hyperthermia is an inherited genetic disorder. Usually, it's caused by a mutation in a single gene. It's this hidden flaw, this vulnerability passed down through a family, and it can stay completely silent for a person's entire life until they're exposed to one of those triggers in an operating room.
A hidden genetic time bomb that can turn a simple surgery into a fight for your life. I know, it sounds absolutely terrifying, hopeless even. But this story has a hero. You see, medical science didn't just figure out the problem. It came up with a solution. And you have to understand, before this solution was found, the outlook was just grim. If a patient went into a full-blown malignant hyperthermia crisis, their chance of dying was as high as 80%. 80%. It was, for all intents and purposes, a death sentence on the operating table. But then, a drug called dantrolene was developed. It was a specific antidote designed to stop that out-of-control process right at its source, and it changed everything. With dantrolene, the story just does a complete 180. When a crisis is spotted quickly and this antidote is administered, that terrifying 80% mortality rate plummets to less than 5%. It is one of the most incredible turnarounds in all of emergency medicine. All right, so we have covered a lot of ground here, right? From your everyday normal temperature all the way to this wild genetic crisis. So let's pull it all together and take one last look at the full temperature spectrum. This chart really lays it all out for us. You can see the whole range from hypothermia on the cold end to our normal neighborhood of normothermia. And most importantly, you can see the key difference again between a fever, where the body's thermostat is raised, and hyperthermia, where the body is just overheating. Then you see the emergency zone of hyperpyrexia, and right there in its own special scary category, the anesthetic-triggered crisis of malignant hyperthermia. And that's where we land. A single, tiny flaw in the genetic code, a totally routine medical procedure, and a sudden life-or-death race against time. The story of malignant hyperthermia is this powerful reminder of the secrets that are still locked away inside our own DNA. And it really makes you wonder, doesn't it? What other hidden risks are just waiting for the right key to unlock them?